Greetings to all. In this video, we are going to see about pulse transformers. The pulse transformers is known as trigger transformers or gate drive transformers, gate transformers or signal transformer or wideband transformer. Pulse transformers, if you look at this pulse transformers, you can see the fundamental difference between the conventional transformer and pulse transformers. The pulse transformers, the windings are at the circular shape. This is called a toroid. So the pulse transformers are made up of toroid like structures. This structure is made up of the ferrite core, and among this the windings are made. And here we have the, it's similar to conventional transformer. It is also working on the mutual coupling principle. The main function of the pulse transformer is to transmit voltage pulses, whereas the conventional transformer will transmit the low frequency waveforms similar to the sine wave, whereas the pulse transformers will transmit the pulse waveforms. So these transformers are used for isolation similar to the conventional transformers. This also provides the electrical isolation between the primary and the secondary windings. This transformers, by using this transformer, amplitude in voltage pulse can be changed. The polarity of the pulses can also be inverted. Um, Pulse transformer consists of primary and secondary windings similar to conventional transformer. Primary winding is connected to the input circuit and secondary winding is connected to the output circuit. This is an example of the pulse transformer where this core is in the toroidal shape. This circular shape is nothing but a circular ring like a structure in that the primary and secondary windings are made. There are two secondaries as S and S dash. If you look at the winding number of windings, it will be same as the pulse primary to the secondary. That is the basic difference between the conventional and pulse transformers. The core is typically made. The core is nothing but the circular shape rod. The core is made up of the ferrite or other high permeability materials. That is mu permeability. Mu will be taken as greater than some highest values, greater than nearly it's greater than 10. The operation of a pulse transformer is based on the principle of electromagnetic induction, as I mentioned earlier. It's coupled. The primary and secondary are coupled due to the induction. The turns ratio of the primary and secondary will be like 1 is to 1 or 1 is to 5. It's a very low turns ratio. So here, the one of the application is shown here in the circuit. We have a pulse generator circuit which is going to generate the pulses. This pulses will be transmitted from the primary to secondary. If you look at this, the primary windings are 4, that is equal to the secondary windings. That means this is the 1 is to 1 transformer. So when we have more than one secondary windings, we can call it as 1 is to 1 is to 1 transformers. The one first one denotes your primary winding ratio, and second and third is denoting the secondary winding ratios. So the reason why the 1 is to 1 transformer means there is no impedance matching, or there is no voltage or current scaling between the windings. So whatever is the magnitude applied here, the same value will be passed to the secondary of the transformer by mutual induction. So this pulses are again passed through the diode and RNC circuit to the gate of the SCR, and this is nothing but your SCR. We have anode, cathode, and a gate supply. Usually, the SCR will be having the characteristics like that. When we are increasing, that is, this is between anode cathode voltage to anode current. When the voltage is getting increased till the gate triggering it, there will be no current. Once the gate voltage is triggered, when the gate current is triggered, it starts to conduct the current. This is called your breakover voltage. This is the characteristics of uh, SCR. So, triggering of the gate is important to make the SCR to turns on. Whereas, even though whatever may be the voltage till the breakover voltage, whatever may be the VAK anode to cathode voltage, the SCR will be in the off position. So, based on that, the gate current is applied through the pulses. So, here the pulse transformer is used to apply the gate pulses. Since it is maintained at 1 is to 1, only three windings in the primary and secondary, it is maintained as 1 is to 1. The same amount of magnitude is transferred here. When we go for this kind of pulse transformers that is shown in the figure, if we have one primary and two secondary windings. This is called as 1 is to 1 is to 1 pulse transformer. In the SAR applications, we have RNC circuits. This RNC circuits are provided for the similar to the integrations integrator. This series resistor is stopped to hold the stop the holding current of the SCR. The main function of the diode is to avoid the gate current. The transformer design is discussed here. Once the design is done, the transformer efficiency must be high, the primary windings inductance and the transformer must be high for decreasing the magnetizing current. DC supplies through the main winding of the transformer is to avoid the this is one important point here. The DC current is supplied through the main winding. If you look at the pulse shapes, this is the pulse. For some small time amounts, that small time increments, it is maintained as a constant value like a DC. Usually, the inductor offers XL will be 0 for DC current. Inductor offers short circuit for the DC current, so it will not give any reactance to it. It will be sending the DC current as it is. It's all about the pulse transformer. This table shows the difference between pulse transformer and conventional transformer. Pulse transformers are used for that is designed for the purpose to transmit the high voltage short duration electrical pulses. That is the short pulses, short duration electrical pulses, in the sense your on time is very less. Maybe the off time may be on time may be controlled by the external circuits, so that the off time will be little longer compared to the on time. That is called short duration, and we can transmit the high voltage. Whereas conventional transformers are for the step up and step down purposes it is used. It provides the impedance matching. When we go for step up and step down principles, the impedances of primary and secondary sides are varying, so it provides this impedance matching. The operating frequency is in terms of kilohertz. That is called baseband signals. Pulses are called as baseband signals. In terms of in terms of kilohertz to megahertz, the high frequency pulse transformers are utilized. Whereas this is conventional transformers are used for sine waves, and it is for 50 to 60 kilohertz. The waveforms is also like the sinusoidal waveforms. Remember that all our households or that is the AC current. We have the AC current of we have the AC current of 50 hertz supply. This is stepped down by the transformer circuits. You can see all your transformer circuits in at the street ends. All these transformers are nothing but the conventional transformers, which will be working of the 50 to 60 hertz sinusoidal waveforms. Whereas in the pulse transformer, rectangle pulses are used with the faster, that is almost zero fall time and rise time. This is called faster. Rise time is nothing but the time taken to change the value from 0 volt to 5 volt or 0 to 3 volt, whatever may be the magnitude. Fall time is the reverse one. This is the fall time. You might have studied at the digital electronics. So the pulse shapes, that is, pulses are rectangular pulses are used with this almost zero fall rise time and fall time. Both the conventional transformer and pulse transformers are used for the electrical isolations, and it's also used for the energy transfer. Whereas pulse transformer do the energy transfer with pulse width and short time durations, whereas conventional transformers do the energy transfer with the continuous sinusoidal waveforms. Core material is here in pulse transformer we have used the ferrite materials or high permeability materials where the mu r is greater than 10. Whereas in conventional transformers we use the high permeability silicon steel, laminated silicon steel materials are used. Leakage inductance is high leakage inductance here to minimize the pulse duration, whereas this conventional transformer uses the uh, normal transformer normal that is a conventional transformer use the sinusoidal waveforms of 50 to 60 hertz, so the leakage inductance will be very very less, so that the core losses are minimized. This is the difference between or comparison between pulse transformer and conventional transformer. There are two types of pulse transformers. One is called a power pulse transformer and another is called a signal pulse transformers. Power pulse transformer is nothing but used to provide the controlled power in terms of pulses, whereas signal pulse transformers are used to drive the FET and SCR circuits. What we have seen as the example is SCR driving circuit, that is called signal pulse transformers. The applications of pulse transformers are signal transformers are used in telecommunication and digital circuits. Power pulse transformers are used to isolate the high power circuits from the control circuits. And high voltage pulse transformers are used in radar applications. We have a separate class of radar called as pulsed radars, where which will be transmitting the pulses only. For these kind of applications, the high voltage pulse transformers are used. It's also used to drive the power electronics component like SCR. SCR is a sort of power electronic components, and it is used in digital electronics, communications. All these are some of the applications of the pulse transformers. With this, we are concluding the lecture about the power pulse transformers. Just it is introducing the pulse transformer. Based on this applications, we will be studying about the blocking oscillators in the next lecture. Thank you all.